Okay, welcome back everyone. This is the third video. This is going to be quite short. We have so far answered these two questions, how fast and how far. And we have two equations which I'm going to summarize. The first equation is that final velocity equals initial velocity plus acceleration times time. And we talked about that throwing a ball up and down. So this is a vector equation. Pluses and minuses make a big difference, so be careful on how you use them. We also introduced an equation that looks like this. And that equation allows us to determine how far an object falls or moves. And this is in a gravitational field where you might have acceleration. And we also can account for any initial velocity that the object may have, either up or down. Again, this is a vector equation, so your pluses and your minuses are very important. There is one more equation, and I'm not going to derive it. But it's a very useful one. And in this last equation, you can get this one by combining the first two and doing the magic of math. All right? So in math class, you know that if you have two equations that have the same variable, that you can eliminate that variable. So in this last equation, we're going to eliminate time. And again, I am not going to derive it. I'm just going to say this is the result. And so this last equation says that if you take v final squared, you can find that by saying that's equal to the initial velocity squared plus 2 times the acceleration of the object times the displacement. And like I said, I'm not showing you where this comes from, but one of the really nice things about this equation is that it does not involve the variable time. And so you are going to find that there are sometimes physics problems that ask you to solve for one of these things, but they don't tell you anything about time. Okay? So these three equations together can allow you to solve any situation where you have constant acceleration. And so the most important example of that is gravity. And so most of our examples with constant acceleration are going to involve things in free fall. But you can have other situations also that have constant acceleration. And if you do, you can use these equations. Feel free to do it. So I'm going to put a box around these and just make the point that this is very, these are important equations. These are called the kinematics equations. So kinematics equations. And you can use them only with constant acceleration. All right. I think we've got enough down here. What you're going to do is some practice, and please go to the Physics Classroom website, and you're going to do a number of practice problems. Those are the check your understanding problems. So I will let you follow the directions on our post for today. But notice that the answers are given along with the work. And one thing that I really want you to be doing when you solve these problems and check your work is you have to write the formula down. You need to write the formula. I mean the symbols, right? So write these. Okay? I want you to show your work. That means tell me the numbers that go into them. Okay? So you're writing a formula, you're showing your work, and when you get a final answer, I want you to make sure that you include the units. Okay? So never, ever, ever just give me a naked number like 5. You got to tell me, is it 5 meters, 5 seconds, 5 meters per second squared, etc. So when you do your practice on paper in your notes, you need to follow those steps. And when we have any quizzes or tests, I will need to see those that you do. Okay? So good luck. I'll see you later.